Dear students, in this question, in the circuit shown, initially there is no charge on capacitors and keys S1 and S2 are open. The values of the capacitors are C1 is 10 μF, C2 30 μF and C3 is equal to C4 which is equal to 80 μF. Here circuit is given. For the circuit, capacitors are there, resistors are there and some potentials also placed, and initially S1, S2 is open and capacitors are initially no charge, and he is saying that which of the statements is are true, which of the statement is are true. So here four options are there, so one by one we have to check which option is correct. So first option here, what is given is the keys S1 is kept closed for the long time such that the capacitors are fully charged. So initially S1 is closed and is kept for long time such that capacitors are fully charged. Now key S2 is closed. At this time the instantaneous current across 30 ohm will be 0.2 ampere. So here he is saying that initially S1 is closed. After a long time, then S2 is also closed. Then after that, what he is asking? He is asking that find the current through 30 ohm resistance. So here, if you see the one word here, the long time. So whenever in the circuit the capacitors are there, two words are important. First one is the long time, and second one is at t is equal to 0. Why? Because at t is equal to 0. At t is equal to 0, the charging capacitor, which means initially it is not charged, now we are going to charge. At t is equal to 0, charging capacitor behaves as a conducting wire. Conducting wire. And at t is equal to infinity, capacitor acts as an open circuit, which means no flow of current. So here the statement is given that only. In this case, here two situations are given. One, at t is equal to 0, S1 is closed. After a long time, then here is saying that S2 is closed. At this time, the instantaneous current across 30 ohm will be. Now see how to solve this question. Now for example, if you modify the circuit, modified circuit. Initially S1 is kept closed, S2 will not be there. So here C4 will be this one, C4, and 5 volt battery and 30 ohm resistance, and here will be C1, and here one more resistor is there, and this is 70 ohm, and as S2 is open, no need to draw this one, and here it will be 100 ohm, and here capacitor is there. Capacitor C3 is given. Here no need to draw the center one, but because S2 is open. Now see, after a long time, which means the capacitors are fully charged. When the capacitors are fully charged, then there will be no flow of current in the circuit having capacitors. That means here, after a long time, when the capacitors are getting fully charged, there will be no flow of current. Current will not flow in the circuit. Then if there is no flow of current, then this resistance also will not work. Because it does not draw any potential. There is no current, then V is equal to IR, V is also 0. So again, if I modify the circuit, this one will be modified as capacitor C4 will be this one, C4, and here C1 will be there, and here one potential is there, 5 volt, and here C3 is there. C3. Now again, if you want to modify this circuit again, we can modify this one as here 5 volt potential is there, C4, C1 and C3, which means when S1 is closed, at that time this C1, C4, C3 are connected in series with 5 volt. Now we know how to solve. So we will find out the effective capacitance and how much of charge is flowing through the circuit. See, this is a modified circuit and all these capacitors are connected in series. So effective capacitance C is equal to C1 plus C2 plus C3. It is in series. In series, we have 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 in series formula. So 1 by C can be written as 1 by C1. Here C1 is how much? 10. So I will write 1 by 10. And this is C4, C4 and this is C3. So C4 and C3 is equal. C4 and C3 is given as 80 and 80. So here 1 by 80 plus 1 by 80. Mu f we will put after. So 1 by C can be written as 1 by 10 plus 2 by 80. 1 by C is equal to 1 by 10 plus 1 by 40. 1 by 40. So I will write here. So 1 by C is equal to 40 plus 10 by 400. And 1 by C is equal to 500. So 50 by 400. C is equal to 400 by 50. So C is equal to 8 mu F. 8 mu F. If you modify this capacitor, this circuit again, it will be 5 volt. And again here 8 mu F capacitor. So now we can able to find out how much of charge is flowing. We know Q is equal to C into V. How much C we got? 8 mu F. Into how much it is? Potential is given as 5. So Q is equal to 40 microcoulombs. So 40 microcoulombs is the charge in the circuit. So in C1, for example in C1, Q1 can be written as in series charge remains same. We know already. In series charge remains same. For C1, Q1 is equal to 40 mu C. And V1 can be written as Q1 by C1, which is equal to Q1 is 40 microcoulomb and C1 is how much? C1 is 10 microfarad. So V1 can be written as 4 volt. V1 can be written as 4 volt. And similarly, C4, C3 is having same capacitor, same capacitance, and same charge is flowing. We can write for C3 and C4. Directly you can solve. For C3 and C4, Q3 is equal to Q4 is equal to 40 mu F. Q3 is equal to Q4 is equal to 40 mu C. And we'll write V3 is equal to V4 is equal to Q by C. So 40 mu C by 80 mu F, which is equal to 0.5 volt. 0.5 volt. Now try to understand, when 5 volt potential is applied across these capacitors, each capacitors having charge of Q1, Q2, Q3 and V1, V3 and V4. I hope you are understanding. Now our target is to find out the current flowing through 30 ohm when the switch is closed. Now we will do. Now in this situation, when S1 is closed, we calculated the things. Now what he is saying? He is saying that now the key S2 is closed at this time. At what time it is? S1 is closed, and after a long time, S2 is closed at that time. At that time, Initially capacitor is having some charges. Capacitor is having some charge. At t is equal to 0, the charged capacitor at t is equal to 0, the charged capacitor behaves as a cell. Behaves as a cell. Now we'll see. For example, now S1 is closed. S2 is also closed, for example. Now see here, this is 5 volt potential, and here it will be minus and here it will be plus. This is plus, so this plate will be positively charged, and this plate will be negatively charged. And this is minus, so here it is minus, negatively charged, and it will be positively charged. And it is minus, so here it is negatively charged, and so here it is positive charge, and here it will be positive charge. Due to the process of induction. Due to the process of induction. And this is minus, minus, and minus. Now at t is equal to 0, when S2 is closed and at t is equal to 0, all capacitors acts as a cell having some potential. So if you modify this circuit as, see here, C4 I will write as this one. C4 is having potential of 0.5 volt. It's 0.5 volt. And again here is 5 volt. 30 ohm. And this one capacitor C3. C3 is having potential of 0.5. That means here it is minus and here it is plus 0.5. And from the point P, I can write S2. Initially, S2 is not charged one. So at t is equal to 0, uncharged capacitor acts as a conducting wire. So directly I will write here 30 ohm, and here it will be this one. And here C1 acts as a potential of C1. How much it is? 4 volt. 4 volt potential. And here resistance is given 70 ohm. And here one resistor is there 100 ohm, and this joint. I hope you are understanding. At t is equal to 0, when S2 is closed, initially it is not charged, that's why it is behaving as a conducting wire, just a normal wire. And charged capacitors behaves as a cell, having potential what we calculate. Further, we will solve. This is the modified circuit. Now we are going to calculate the current across 30 ohm resistor. Current across this one we have to calculate. And again we can modify the circuit. Just see, I will modify the circuit. This one is 4 volt and 70 ohm, and here 30 ohm, and this one 10 volt. And now in this region, out of 5 volt, 4 volt is here, 1 volt is here, and these cells are reversely connected to this one. So here the net potential I can draw, it is 4 volt. And one more, this 100 ohm and this 30 ohm, these two are connected in series. So in series it will be 130. This is a modified circuit. Again here I can apply loop rule. By using loop rule I can able to find out how much current flowing through 30 ohm resistance. Now see here, by applying KVL I will find out, I will try to find how much current is flowing across 30 ohm resistance. For that, just I am assuming current is in this loop like the current is in this direction, it is I1, and in this direction it is I2. So I will follow from this point, and it mentioned here is P and it is Q here. I will mention it is R and it is S. So I will start from SQPR. SQPR. In this direction I am moving. So here 10 volt. Why? Because I am moving from low potential to high potential. That's why I wrote 10 volt. Minus here the current is I1 and here the current is I2. Current is I1 and current is I2 across 30 ohm. So I will write minus I1 minus I2 into 30 minus 4 volt and minus 70 I1 is equal to 0. I will write 10 minus 4 means 6 minus 30 I1 plus 30 I2 minus 70 I1 which is equal to 0. We have to find out the expression for I1 and I2, and simply we have to follow for the loop 2 also. I will write SQPR loop 1. Loop 1. We will see here. Minus 30 minus 70. Minus 100 I1 plus 30 I2 which is equal to 0. So here minus 100 I1 plus 30 I2 is equal to minus 6. So 100 I1 minus 30 I2 is equal to 6. So here 6 is there, 130. So we can take 200, will get cancelled. So 50 I1 minus 15 I2 is equal to 3. So this is first expression. And similarly, I will follow for the loop 2. For the loop 2, and I will find out that equation 2, and I will solve equation 1 and 2. I will try to find out the values of I1 and I2. After I am getting I1 and I2, I can find out how much current is flowing across the 30 ohm resistor. Now see here, loop 1 I got one equation. I will apply for the loop 2, and I will write TU. So loop 2, I will start from here. In this direction, minus 130 I2. In this direction, plus 4. In this direction, minus I2 minus I1 into 30 minus 10 is equal to 0. Minus 10 is equal to 0. Again, I have to simplify this equation. So 130 I2 plus 4 minus 30 I2 plus 30 I1 minus 10 is equal to 0. Here minus 10 plus 4. So here it will be minus 6. And again minus 30 I2 minus 130 I2. So minus 160 I2 plus 30 I1 is equal to 0. 30 I1 minus 160 I2 is equal to 6. So here also we can take 2 as common. So 2 as common. No need to take 2 as common. 2 we can take here. So we will get here 15 I1 minus 80 I2 is equal to 3. It is second expression. I got expression 1, expression 2. From these two, I have to find out the values of I1 and I2, and after that, I will find current across 30 ohm resistance. See, from 1 we can write divide with 50. Divide with 50. So I1 minus 15 by 50 I2 is equal to 3 by 50. Is the third equation. And from 2 divide with 15. So I1 minus 80 by 15 I2 is equal to 3 by 15. 4. Now from equation 3 and 4, I will try to find out the values of I1 and I2. Just see, I will do minus. minus, plus and minus. This one will cancel. So here I will take I2 as common. I2 as common means 80 by 15 minus 15 by 50 is equal to 3 by 50 minus 3 by 50. So by solving this one, I will get the value of I2. By solving this one, you will get I2 is equal to 0.02. You will get actually 0.027 is getting, but 0.02. I will substitute the value of I2 in any one of the equation, and I will try to find out the value of I1. So from 3, I will write I1 minus 15 by 50. I2, what is I2? 0.02 is equal to 3 by 50. Again, by solving this one, I will get I1 and I2. Once you will get the value of I1 and I2, then you can easily find out how much current is flowing through 30 ohm resistor. And by solving this one, we got I1 is equal to 0.01. So if you observe 30 ohm resistor, across 30 ohm resistor, I1 is in this direction. I got I2 is downward. I2 is how much? Minus 0.02, which means the direction of current will be in this direction. So we can write directly across 30 ohm, I will write again I1 and I2 and we will discuss. And now we will see across 30 ohm resistor, we will write I is equal to I1 plus I2, which can be written as 0.05 plus 0.02, 0.07 amperes. Current across 30 ohm resistor is 0.07 ampere, but in this option it is given as 0.2 ampere, so which is wrong. So option A is wrong. And now we will see option B, C, D. Let's see the second option. If S1 is kept closed for the long time, such that capacitors are fully charged, the voltage difference across the points P and Q is 10 volt. How much is saying? The voltage difference across the point P and Q is 10 volt. But in the first case itself already we solved. Across C1, how much potential difference we got? We got 4 volt. Across C1, how much potential difference we got? 4 volt. So which means we are considering here it is 0 volt. So here it will be 4 volt. But because across C1 how much potential? 4 volt. This one and this one is parallelly connected. So in between these two also, how much potential should be there? The potential is 4 volt. Which means potential difference between P and Q is 4 volt. But in option B is given that 10 volt, which is wrong. Again we will write option B is also wrong. Now we will see option C and D. Now see, in option C, he is saying that at t is equal to 0, the switch S1 is closed. The instantaneous current in the closed circuit will be 25 milliampere. Now again he is saying that at t is equal to 0, when switch S1 is closed. So at t is equal to 0, uncharged capacitors behaves as a conducting wires. So we can write at t is equal to 0, if you modify the circuit, modified circuit will be, how it will be modified? It is closed, capacitor acts as a conductor. So directly here I will write one potential which is 5 volt, one resistor 30 ohm, it acts as a conducting wire, and here one resistor is there. How much it is? 100 ohm, and here capacitor is there. At t is equal to 0, this capacitor acts as a conducting wire, and here 70 ohm resistance is there. 70 ohm. Now see, in this situation 100, 70, 30. Again modify. Total 200 ohms, and again 5 volt. 5 volt capacitor. And if you want to find out, V is 5 volt is given, I is equal to V by R. V by R. So 5 by 200. 5 by 200. We can write 5 into 10 power minus 2 by 2. So I is equal to 2.5 into 10 power minus 2. We can write 0.25 into 10 power minus 3. 0.25 into 10 power minus 3. That we can write I is equal to 25 milliamperes. So what is given in option C? At t is equal to 0, the switch S1 is closed. The instantaneous current in the closed circuit will be 25 milliampere. So we got the same answer. So option C is the correct one. Finally, we will verify the option D. See here, last option what he is saying, if the key S1 is kept closed for the long time such that capacitors are fully charged, the voltage across the capacitor C1 will be 4 volt. So he is saying again, when switch S1 is closed after a long time, the voltage across the capacitor C1 is 4 volt. So this is what we got already. So we got in the first option itself, we got the potential across the capacitor C1 is 4 volt. It is given in the last option, 4 volt. So option C is also, option D is also correct one. So for this question, A, B, C, D, A, B are wrong and C, D is correct. I hope you understood. It is somewhat lengthy question, but by practicing it will be easy. And in order to understand only, I explain each and every point so that every student can able to understand easily. Thank you.